Okay, so for the test tomorrow, the first kind of problems you want to know how to solve are the law of sines. Okay, this is one that you can tell it's a law of sines just by looking at the table. Okay, how can you tell? Yeah, David?
We have one full row.
Okay, we have one full row. And how can you tell that it's the case where you got to check for 0, 1, or 2 solutions?
There's like one row that's...
Yeah, you have one row that's empty. So first thing we're going to do is solve for beta because it's the only thing we can solve for right now. Okay. Any questions on why we have to solve for beta? All right. So how would I set up my law of sines to solve for beta? Yep.
You do sine of 30 degrees over 7 equals sine of beta over 8.
That's good. Sine of 30 over 7. Sine beta over 8. And to get sine beta by itself, how would I move 8 to the other side?
Cross multiply. So like 8 sine 30 equals 7 sine. Or you can just multiply by 8.
Yeah, in this case, since we're trying to get sine beta by itself, it's easier if we just multiply both sides by 8. If you cross multiply, then you'd have to divide by the 7 again. All right, so I'll just leave it already divided by 7. Put 8 sine 30 divided by 7 equals sine beta. Okay, now how do we get beta by itself?
You do inverse sine.
So, inverse sine of what's on the left and on the right. And now we type that in. Okay, if 8 sine 30 divided by 7 is bigger than 1, then what would happen? It would be no solution. Okay, you can't take the inverse sine of a number bigger than 1. So if we type it in and we get an error, that would be no solution. Okay, so type 8 sine 30, make sure you close your parenthesis, divided by 7. Okay, so this is not a no solution. Okay, so one of the solutions for beta is 34.85. Right, so beta is 34.85, and I'm going to call that beta 1. And what do we do with that answer to check for the second answer? And remember what you do with that to get the second answer?
Add 180.
Yeah.
Subtract it from 180. So if there's a second answer, it would be 145.15. Does that work?
Does.
Yeah, basically anytime that the angle you're finding is bigger than the given, it'll always work. Because you just subtracted something bigger than 180, bigger than 30. Right? So then when you add 30 back to this, it's still under 180. Does that make sense?
So then,
The other beta is 1.
Yep. All right, and that means we're going to have 2 gammas. And we're going to have 2 C's. All right, so how would we get gamma 1?
You're going to have 34.85 plus 30 and then subtract that answer from 180.
Yep, so we got the 30 and 34, so that's 64. And then subtract that from 180. So gamma 1 is 115.15. And how would you get gamma 2?
Do 180 minus 175.15.
Yeah, so it's going to be pretty small because you've already used up 175.15 for the other 2 angles. So we're going to get 4.85 degrees. Okay, now that we have a piece of information in the last row, we can use gamma 1 to find C1, and we can use gamma 2 to find C2. So besides the numbers or the rows I just read, what other row are we going to use to find C1 and C2? Yeah, we're going to use the first row, the A and the alpha. So we're going to set both of the proportions up, starting with that. Okay, so let's find C1. So we'll do sine 30 over 7. And what would go on the other side?
Sine 115.15 over C1.
Over C1. Okay, and you'd cross multiply, and then you could solve that for C1. So C1 would be 7 times the sine of 115.15 divided by sine 30. Okay, you just type that in. So now let's make sure we can set it up for C2. Okay, how would it start off for C2?
Sine 30 over 7.
Yep, same thing, sine 30 over 7. And then this time, what angle would we use to find C2?
Sine 4.85.
The 4.85. And that would be divided by C2. Okay, so to find C2, you're going to do 7 times the sine of 4.85 divided by sine 30. And just round that off, and that's C2. Okay, so any questions on that? That's the two-solution case. Okay, the no solution would be a lot faster than this. If you had a no solution, you would start to find the first angle right away, you'd type it in, and you'd get an error.
And then what's just everything no solution?
And if one thing has no solution, everything is no solution. Yep. Okay, so make sure you know how to do the two solution, the no solution, and the one solution. Okay, the one solution is kind of in between. One solution means you would get an angle that works, but then the second one would have been too big. So let's say the second answer here came out to 160. All right, if I look at what was given, I'd say, all right, I had a 30. I got 160 for the second answer. That's too big. Okay? And then if the second answer didn't work, you wouldn't have a beta 2, a gamma 2, or a C2. Okay? So that's pretty much the only case you have to worry about with law of sines. The side-side angle.
Do you have to find like which solution works, or is that just your answer? Like both of them?
They both, they both work. You do have to figure out if the second angle works, though, by adding it to 30. And if it works, then everything works. Yep. Okay, so that's that one. Okay, another one you're going to have that's more of a word problem. So it's, kind of give you an example. So like if you had a, like a tower, okay, it's going to have something like that on it. So here's your tower. And the tower, it's going to say, has a wire coming from it. So on the test, I actually give you a diagram to kind of help you to start. And it says that the wire makes a certain angle with the ground. Okay, say like, I don't know, 50 degrees. And then it says at a point, say, 20 feet further away from the tower, but on the same side as the side with the wire, we have another line. So how would I draw that? What would that mean? At a point on the same side as the tower, but 20 feet further away from where the wire hits the ground.
Maybe like 20 plus x, really.
Like if this part was x?
Yeah, if that was x.
Yeah.
20.
So this part would be like, so what would just this part be? Yeah, that's a point 20 feet further away on the same side of the tower as the wire. And it'll say something like the angle, if you were to stand here, the angle you would have to look up at to look right at the top of the tower would be something like 20 degrees. Okay, so the question here would be to find, you can find a couple things. Let's just, let's find the length of the wire. Okay, find the length of that solid red wire. So basically the triangle you're working with is right here. Okay, what's some information I can label in that green triangle?
The obtuse angle is 130 degrees.
Yep, I know that one. I know this one
130 degrees.
is 130. I know this side, yeah, it's 20 degrees. It also happens to be, I said, 20 feet from here to here. What else do I know? Yep, that angle would be 30. So I know all the angles, and I know one of the sides. So I could set up a law of sines to solve for x. Okay, as far as setting up the law of sines, I'm going to leave that part to you. But what kind of triangle would this be, like using the 3 letters? Yeah, you could look at it as you know an angle, you know a side, and you know another angle. So you could look at it as ASA. What's another way you could look at it? Yeah, you know an angle, you know an angle, and you know a side. Okay, so no matter which way you decide to look at it, both of those are law of sines problems. Okay, so for the word problem, you do want to make sure you would know how to set up the law of sines to solve something similar to that. So that's the first 3 questions on the test, law of sines. Then law of cosines. About 12. Yeah.
Isn't the table on the test that the other class had like 9?
Yes, they have a different test. Yep, different. Yeah, it's totally different. But yeah, it is 9 questions.
Oh, so what is it, 3 per section?
It's about what it comes out to, roughly. Some sections might have 2 and 4, like that. There's a couple questions on law of cosines, only 2. So let's look at a side angle side problem, because what you have to do in a side angle side problem is also partly what you have to do in side side side. Okay, it kind of covers both. So let's say we had something like, we have a side that's 10. Let's let that be A. I'm going to let C be 15. And I'm going to pick an angle, but I can't pick an angle that would be in the same row. So I have to pick beta. Okay, let's let beta be 40 degrees. How do you know this is law of cosines?
Because there's no full row.
Yeah, you don't have a row with everything in it. But because of this kind of problem, you're forced to use a certain law first. So we talked about the 3 versions of the law of cosines. This time you have to use the one that starts with what letter? B, right? Because the one that starts with B has beta in it. Okay? So we're going to start off with B squared. And what would come next?
B squared equals A squared plus C squared.
Okay.
So that would be 100 plus 225.
It's 225.
And then it's minus 2 times 10, which is 20 times 15.
All right, so we'll do that out in a second. So 2 times 10 times 15. Cosine 40. Okay, so this is the type where the variable is by itself pretty much. The only thing you're going to have to do at the very end is take a square root. All right, so we've got b squared, 100 plus 225. And then 2 times 15 is 30, and then 30 times 10 is 300, times cosine 40. Okay, what would you do next?
Divide.
You subtract 300 from 325.
No, you can't do that because it's attached to cosine. So you have to solve that, type that in the calculator, 300 times cosine 40.
Yep, you got to do multiplication before the subtraction. So now I need 300 cosine 40, which is 229.81. What did I say? 229.81. Okay, if you end up with a bigger number after the subtraction sign, we're going to run into a problem because you can't take the square root of a negative. So far everything looks good. So what is, let's do b squared first. So it's 325 minus 229.81.
Yep.
So we get 95.19. And my last step,
You go square, you go find the square root.
yep, take the square root. Again, this is all approximate, but that's okay. So 9.76. Okay, so the only time you have to take the square root is when you're solving for a side, which obviously never happens in side, 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 because you're given all the sides. So B is 9.76. All right, so now we need to find the angles. We can find alpha or gamma, because now that we know all the sides, we can use either law. So do you want to find alpha or gamma? Alpha. Okay, so what we're about to do right now to find alpha, this was to find B. This is what you have to do in a side, side, side problem. Okay, so now we're doing the calculation, exactly the same calculation you would do in a side, side, side problem. Okay, so the law of cosines that starts for alpha, how does that one start?
Start finding alpha. You're doing a squared.
Right, so a squared is 100.
100 equals b squared, so that's
Which I have right there.
95.19 plus 225 minus 2 times 225 and 95.19.
So it's minus 2 times what?
2 times the 225, or well, the 95.1991, and then the times c.
So can you give me the formula? Because you're not using the right numbers. It's minus 2.
Oh yeah, it's not squared.
It's not
It's
squared.
15.
It's just
the
2BC.
9.76.
So yeah, 2B is 9.76 and C is 15. Cosine alpha. Okay, so the 95 and the 225, we can add those up. So I get 320.19 minus, and the 2, the 9, and the 15, I can multiply all that out. So 2, 9.76 times 15 gives me 292.8 cosine alpha. Now, this type is different because you're solving for the variable and it's inside the cosine function. Okay, so our goal now is to get cosine alpha alone. So what would I do next?
Whoa. Thank you.
Would you like subtract the 320.19 to the other side and then divide by the 290?
Yep. So we'll subtract the 320. What's 100? Well, let me just do it out. Sometimes it's a little tricky to think of the decimals, but it's negative 220.19. All right, so we get that equals. And now what did you say to do after that? Divide by?
Divide by negative 292.8.
Yep, so I'm going to do that in the same step. Divide by 292.8. And I'm just going to leave that. I'm not even going to do this out to avoid having to round even more. So now, what would I do to get alpha by itself?
Inverse cosine.
Inverse cosine of all the stuff we had up above. If you're ever doing inverse cosine and the top is bigger, don't even bother typing it in, because you can't take the inverse cosine of a number bigger than 1. Okay, since the bottom is bigger here, I guarantee when I divide this, it's less than 1. Okay, that's why I was able to make up a side angle side problem, because I can't really mess anything up just making up one of those. All right, so inverse cosine of 220.19 divided by 292.8. Okay, so alpha is 41.23. Okay. Now, how can you find gamma?
Subtract. We'll add those two up and subtract from 180.
Okay, so that's one way to do it. Just add alpha and beta, subtract them from 180.
Or you solve, do the whole process again.
Yeah, or you can go through and do this calculation again, except do it for gamma instead of alpha. What I'm going to do is I'm going to just subtract from 180. Okay? On law, if you're doing a side-side-side problem, you would have to do it again. Okay? You have to, because you're missing all the angles, you have to do it at least twice. And then you can add up and subtract from 180. Okay? So we add these up, we get 81.23. So 98.77. Okay, so any questions on how to use law of cosines to find a side or to find an angle? Okay, so that's pretty much the end of the 8182 stuff. So the last part is all on the imaginary numbers. So we talked a little bit about graphing. Okay, any questions on graphing a complex number? That's pretty straightforward. But dividing, okay, you have to make sure you remember how to divide the old way.
So is at least 6 questions about that? The 81 and 82?
It's more like five or six maybe. Yeah, right around there.
Remember, was it not the one with like the imaginary numbers divided?
Yes.
And the x is the real number? Okay.
Yep. So let's say I asked you to divide this. And that's not in trig form. Okay, that's the old way. How would you divide those two numbers?
Oh, you're going to multiply by the reciprocal of the bottom.
I do like multiplying by
Not
the
really reciprocal,
something.
just you change the sign.
So what would it
it's
be?
4 plus 5i.
Yeah, you remember what that's called?
No.
Anyone remember what that's called? When you change the sign of that middle part? No, not the inverse. You do this sometimes in a foreign language class. This word that you do with verbs kind of sounds like it. Yeah, it's the conjugate. The verb in Spanish, it's conjugate, but this is the conjugate. So a little different. But now we multiply and FOIL that out. All right. So we FOIL the bottom. That one's going to be nice because it's they're conjugates. So when you FOIL, what do you get? Yep.
It's 25.
Plus 4 times 5 is
Oh, that's good.
20i.
29.
So we don't have to write that part down. Plus 20i minus 20i.
Oh, minus 25.
Not minus 25i.
Nice.
I squared. Okay. And now in the top, we do have to write everything
What?
down.
That bottom changes to just plus, isn't it just like, no, isn't it not like 26? No. Isn't I squared negative 1?
Yes.
So it cancels and makes that plus 20, plus 25. 16
Yes.
plus 25.
Mhm. Yep. So we can write that in the next step. So now when we FOIL the top, what do we get there? Yep, 8. So we get a 10i and a 12i. What's 22i? And
15i squared.
and then 15i squared. Okay, so there's a whole bunch of stuff we got to do with this. So at the bottom, Dave said that it becomes plus 25, right? Because I squared is negative 1. Now in the top, what does this become? It's really a negative 15. So what's 8 combined with a negative 15?
27.
That's a negative 7 plus 22i. And that still isn't the final answer because we got to separate it into real and imaginary parts.
So then it's negative 7 over 41 and negative and 22i over 41.
Okay. So that's how we divide complex numbers in standard form, okay, the old way. Let's write one of these numbers in trig form. Okay, so let's take 2 plus 3i and write it in trig form. So let's convert to trig form. In fact, let's convert both of them to trig form, and then let's do division in trig form and see if we get the same answer the way we did it in standard form. Okay, we're going to get decimals. So while I'm here, it might be helpful if I know what these decimals are. So it's about 0.171 plus, it's about 22 over 41, 0.537. That's about what you get if you convert it to decimals. Okay, so now let's change 2 plus 3i to trig form. Okay, what would my radius be?
Square root of 13.
Yep, the square root of 13, because you have 4 plus 9. Okay, you're just doing the Pythagorean theorem on a triangle that looks something like this. Right? And now, the way I drew it, I'm in quadrant 1. So what's the formula for theta?
Inverse tangent of 3.
So inverse tangent of 3 over 2. Okay, and that's about, it's not a nice answer. So inverse tangent of 1.5, 56.31. So what would my final answer be in trig form?
Isn't it like square root of 13 cosine 56.31? Oh, plus sine, or like I sine of 56.31.
Sine 56.31. Yep. Okay, now let's convert the other one to trig form. That was 4 minus 5i. All right, so I'm just going to put a box around that. What was it? 4 minus 5i. Okay, start with our radius. Okay, what would my radius be there?
3.
How did you get 3?
It's not 3.
That was on the triple.
No, it's 16.
This one, the legs are
minus
4 and 5 instead of 3 and 4. Yeah.
25.
So yeah, 16 and 25.
That's 31, 41, square root of 41.
Yep. So you were thinking if the 5 was the hypotenuse. Yep. All right, so the radius here is the square root of 41. And what quadrant am I in? Nope. Nope, not 3.
Okay.
What kind of number is this? Positive. And this one?
Quadrant 4.
Negative. So when you graph
Oh,
a
yeah.
positive negative, what quadrant is that? Write it down. So that's quadrant 4. So what's your formula for theta in quadrant 4?
Quadrants 1 and 4 is just the regular.
formula. So it's theta equals inverse tangent y over x.
Yep. Inverse tangent. What's y?
5.
Nope.
4.
-5.
Nope. Negative 5.
Oh.
So negative 5 over 4. The negative will it makes a big difference. It'll cause your answer to be a negative instead of a positive. Right, so inverse tangent of negative 5 over 4, and we get negative 51.34. All right, so if we write that in the notation that we use, we get our 51.34, yep.
Plus I sine.
Minus I sine.
No, plus I sine.
Well, we didn't fix
Yeah,
the
you-
negative here, so we probably shouldn't fix it in the other part either, unless this is a final answer, then we should fix it. So what would you put here if we don't fix it?
I sine. Negative 51.34.
Yeah. Now, again, if that's a final answer, your two options to fix this are add what to the angle?
360.
360,
Or 2 pi.
in radians, 2 pi. Or what else could you do?
You would take away the negative on the cosine.
You can get rid of the negative on the cosine.
The negative to,
And you do minus.
Yeah, and with the sign, you can move the negative in front. Okay? But what I want to do now is divide these two numbers in trig form. Okay, on the test, I'm going to have you do 2 out of 3 of the operations we learned. So we learned multiplication. Actually, we learned 4. Multiplication, division, powers, and roots. So I'll probably have you do 3 out of the 4 I just said.
You want the sheet? No.
All right, so let's divide these. Since we just divided them in standard form, we already know the answer, and see if we get the same thing in trig form. So what do I do with my radii when I'm dividing?
Well, you're gonna multiply them, or, you're dividing, so you're gonna divide.
Divide them. So it would be square root 13 divided by square root 41. And what do I do with my angles?
Subtract that.
Subtract them. So what's going to happen when I subtract these angles?
You're gonna add.
I'm really going to add them because I'm subtracting a negative.
Yeah.
Okay, so it's going to be 56.31 minus 51.34. Okay, so my angle is 107.65. Okay, now, if I wanted to convert that to standard form, I know I have a root in the bottom. I'm not really worried about multiplying top and bottom by root 41 right now. So I'm going to leave that. But how would I convert this to standard form?
Like square root of 13 divided by square root of 1, and then like that answer times times cosine 107.65 plus that
See what you
times sine 107.65.
Yeah, so I'm just going to take the square root of 13. And there's a couple ways you can type it in. I'm just going to type it in exactly the way it looks. Square root of 13 divided by square root 41. Okay, and we're going to multiply. In fact, what I'm going to do, I'm going to save that answer because I'm going to need it again. So I'm going to just store that as A. So I don't have to type it again. And now I'm going to take A times, what's the first thing?
Cosine of
107.65. And when I do that, I get negative 0.171.
That's what we got up there.
So negative 0.171. Okay, rounded. And the next part, I'm going to take A, because that's what I saved it as, times what? And it's the sine of what? 107.65. And we get 0.537. that part has an I. And when we did it in standard form, we also got 0.537. Okay? So what I'm just showing you that I didn't show you in class is that doing it in standard form and trig form, I showed you it came out the same both ways. So this problem really covered like 4 different things on the test. Converting a number to trig form, doing either multiplication or division in trig form, and converting an answer in trig form to standard form. All those things are on the test. Not necessarily in the same problem like I did here, though. Okay, now if I wasn't going to divide these 2 angles, okay, that I have in the boxes, if I was going to multiply them, what would I do with my R1 and R2? Multiply them. And what would I do with theta 1 and theta 2? I would have added them instead. So make sure you know both for the test. Okay.
Do we have like a formula for that?
Yeah.
Yep.
First one was in there.
Okay, let's just use one of those same things and let's raise one of them to a power. Okay, because we didn't talk about that yet. Okay, so we wrote numbers in trig form. We converted from trig form to standard. Products and quotients. Yep, let's do a power and then a root. For the root, I'm going to pick a new problem because this is going to be really messy. In fact, I think I'm going to pick a new one anyway because I don't really want to deal with the decimal. All right, so let's just simplify. Right, let's say we had 3 cosine 20 plus I sine 20. And I want to raise that to the 5th power. Okay, how would we raise that to the 5th power? Now, how come you can do that right away? Yep.
Because we already have the R, like 3 equals R.
And what is all this called? Yeah, we already have it in trig form. If I ask you to do something like this, you can't just do the same shortcut because you don't have the R and you don't have the theta. Your first step would be to find the R and the theta, and then you could do what we're about to do. Okay? But in this case, I gave it to you. So you do 3 to the 5th, and that's small enough. I would want that one done out. It's not that big. And then what about my angle?
You multiply the angle by the power.
Mm-hmm.
So it's 20 times 5, which is
100. So that's your angle. And what do you get if you do out 3 to the 5th?
I have 2,673. I might have done an extra one.
Well, 3 times 3 is 9, times 3 is 27, times 3 is 81, 81 times 3.
It's
240.
It's 240.
I got an extra one.
All right. So that's, again, small enough. I would prefer that one done out. So 243 times cosine 100, I sine 100. And if I wanted that in standard form, what would be your next step? But we're not going to do it out here.
You could just do like 243 times cosine of 100 and then 243 times sine of 100.
Yep. And just don't forget to put the I after it.
After.
Yep. So that would be how you convert it to standard form. Yep, but we'll leave that one in trig form. And some of them on the test you can leave in trig form too. Okay, any questions on that? All right, so now let's find a root. Do you want to do a cube root or a 4th root? A 4th root. So let's find the 4th roots and pick a number.
13.
13. So we're going to get some decimals here. That's fine.
All right.
So we're going to find the 4th roots of 13. What's the equation I have to set up to do that? I'll give you a hint. It has an equal sign.
Z to the fourth equals 13.
Yeah. Z to the fourth equals 13. Now, what do we replace Z with?
Parentheses, cosine, no,
No,
R.
R cosine
R cosine theta.
plus.
And what power are we raising that to? We're raising that to the fourth power. So we can either raise it to the fourth, or we can just do it outright in this step. So if we do it out, then we don't have to rewrite it.
R4.
R4 like that?
R to the fourth.
Ah, okay. Okay, so that's the left-hand side. And now the right-hand side, we have to write that number in trig form. So 13, what's the imaginary part?
0.
Yep, didn't give me imaginary part, which may or may not happen on the test. So this one, the angle is going to be easy to find because you're on an axis. How would you graph 13?
Over 13 to the right.
Right 13. So if you go right 13, what's the distance from that point to the origin? 13. You don't need Pythagorean theorem because all you did was move straight in one direction. Okay, and your angle, if you go to the right,
0.
is 0. You don't need inverse tangent of y over x. Okay. So cosine 0 plus I sine 0. Okay, now we got to set up two equations. What's going to be the equation for my radius?
Oh, 13 squared. Square root of 13.
Nope.
R equals.
Not r. Well, you could do r if you're skipping a step.
R4 equals.
R4?
R to the fourth.
Oh, okay.
Equals 13.
13. And now how would you solve that?
You gotta do the quarter root, fourth root.
Fourth root of 13. That's one that I would just leave that as the radius. It's just the fourth root of 13. Any questions on how to type that in if you had to? In the calculator? I think, we might have done that in class. Yeah.
Yeah, you go
Like
math.
the number, then hit
You
math.
type
then
Yeah.
hit
math.
Math,
Or
it's
math.
the fifth option, yep. Okay, so there's my radius. And how many different answers is this problem going to have?
4,
4.
0, 1, 2, 3.
So we're going to have fourth root of 13 cosine plus I sine. And you're just going to have that 4 times.
I'll copy and paste it.
Yep, just copy and paste it. Might be quicker to just rewrite it. Yeah, I'm having some technical difficulties. Why won't it let me just drag that? Oh. Okay, so just copy it.
I got the homework, there's one with 6.
There's one with 6.
Yeah.
Yeah, so I said on the test it would probably be a third or a fourth root. Not 6. Not that it's that much harder, it's just a little more time consuming. Okay, and now what's the equation for my angle?
Would be 4. Wait.
I don't remember how we
Yeah.
fixed that.
4 theta
Yep.
equals.
Equals
Yeah,
0
0.
plus
Zero plus
360K.
Yep.
And then everything divided by 4.
Yeah, so in this case, the 0 doesn't really make a difference, but if we had a number there that wasn't 0, it would. So theta equals what? And to get your 4 answers, what values will you let k equal?
0, 1, 2, 3.
0, 1, 2, 3. Okay, so what, using that formula, theta equals 90k, what is my first angle? 0. Second angle?
90. 180.
80. And the last one?
270.
27. Now, those are all quadrantal angles, so what's in the parentheses is all going to come out very nice. You're going to get nice answers. So let's just take one of them and convert it. So what's the cosine of 0?
One.
1. What's the sine of 0? 0. So if you convert this to standard form, this imaginary part disappears because it's I times 0. This part is just a 1. What's 1 times the 4th root of 13? The 4th root of 13. So that's one of your answers in standard form, 4th root of 13. Any questions on how you convert those other ones? It's all going to be zeros and ones in the parentheses because the angles are all multiples of 90.
No negatives? Or it'd be negative 1?
Yeah, you might get a negative 1. Oh, yeah, you will. Yep.
Okay.
Zeros, ones, and negative ones.
Okay.
The only other thing for the test is if you had something like, let's say you had this, 2 cosine 60 plus I sine 60. And I said to convert that to standard form as an exact answer. Right? So what would be the first calculation I'd type in to do this in standard form? 2 cosine 60. Okay, I'm going to start with just cosine 60. Okay, that's a half. So that's not too bad. So it's 1/2, and that's exact, plus I times. Now I need to figure out the sine of 60. What is that? .866.
That's pi of 4.
Nope, it's not something with pi. It's not the square root of 2 over 2. That would be 0.707.
3 over 2.
That is the square root of 3 over 2. So those special ones, you need to either know how to calculate them if you have to go back and use the unit circle, or just memorize them. So 0.866 is the square root of 3, just to double check it, divided by 2. And now what would you do with that 2? Distribute it. So what's 2 times 1/2? 1. Plus, what happens when you do 2 times root 3 over 2? Just the square root of 3 times I. So that's the exact answer, converting this to standard. Any questions on that? So you will see one like that that's an exact answer and not a decimal. If the angle was something like that wasn't a multiple of 30 or 45, we would not be doing it as an exact answer. So that's the only time you should expect exact answers, when you have multiples of 30 or 45 for your angle.
What are the decimals of, like, what are the other decimals we should know?
You should know this one. What's the sine of 45? Yep, that one's root 2 over 2. What about the sine of 30?
Square root of 3 over 2. No, that's 60. No, but that was cosine. I don't know.
So what's the sine of 30 the same as? What other trig function? Remember the cofunctions?
Cosine.
Sine of 30 is the same as the cosine of 60, the complement. Those two
Oh,
are
yeah,
the same.
yeah, yeah.
We already know the cosine of 60, we just did it. So what's the cosine of 60?
1/2.
Or the sine of 30? Yeah, they're both a half. So the sine of 45 would be the same as what else?
Cosine of 45.
Yep. So those are the same. What about the sine of 60? That would be the same as what? Cosine of 30. And we already did that one as well. What's the sine of 60?
Sine of 60 is square root of 3/2.
That was root 3 over 2. So as far as sines and cosines, that's every angle that you'd have to know in the first quadrant. Those numbers would just be repeated in quadrants 2, 3, and 4. But what could happen to them in those quadrants?
They can be negative.
They could become negatives. So if you're wondering which one is negative where, just think of your diagram. If you're in quadrant 2, the sine would be the only positive. Quadrant 3 would be tangent. Quadrant 4 would be cosine. We don't really have to worry about tangent too much because trig form doesn't have tangent in it. It just has cosine and sine.
So we'll never have one in quadrant 3 on the test.
Oh, you could have an angle in quadrant 3, but you wouldn't be taking the tangent of it. You'd be taking the sine or the cosine of it. So like if I gave you the sine of 225, you should know what that is.
Square root negative 3 over 2.
No, square root of 3 over 2, that's
Negative
0.866.
2, negative 2 over 2.
That's negative 1.
I have no idea.
You said negative 2 over 2?
Square root of negative 2 over 2. I have no idea.
Can anybody else clear that up a little bit?
No, these things could be.
Negative square root of 2 over 2.
Yeah. So first you said, I'm just being a little picky,
Yeah.
but first you said this, and then you said this,
Yeah.
which would be imaginary, and then you said this, which is correct. It's negative root 2 over 2. Yep.
That was 0.707.
So really the decimals that come up are the 0.707 and 0.866. So there's really only two things to remember. Root 3 over 2, root 2 over 2. If you include negatives with that, then I guess there's 4 things to remember. All right, so De Moivre's theorem, that's the power, and then finding roots. Okay? I'm going to have you find roots the way we did it both ways, okay? In trig form, okay, like we did here, and I'm going to have you do one in standard form. So then you'll have to take and do what we did in red. Okay? And that's pretty much everything that's on the test. So any other questions on that? No? Okay.